Let's take a look at how standard form works and, more importantly, the rules that decide what numbers we put in to a standard form number. Standard form is a shorthand way of writing very large or small numbers. In general, standard form looks as follows. It's written in the form a times 10 to the power of n. Now there are certain rules applying to a and n. A, the number, must be between 1 or 10. It can't be 10, but it can be 1. But it must be a number between 1 and 10. N, however, can take two different types of values. It can be positive if we're dealing with very large numbers, or negative for very small numbers. So it's important to remember what happens to that power if we're dealing with either a very large number or a very small one. If we look at the following example, they want us to write this very large number in standard form. Now what we have to think of is all to do with the decimal place in this number. The decimal place is found at the end of any non-decimal number. So if we take a look at where the point is, we need to now move that point so we create a number between 1 and 0. Now if we move that decimal place 11 spaces to the left, we move it between the 3 and the 4, which gives us a number between 1 and 10, 3.45. We ignore those zeros at the end because we're going to be multiplying 3.45 by 10 to the power of how many spaces we moved the point. So in this case, that number becomes 3.45 times 10 to the power of 11. Now if we take a look at an example with a very small number, such as this one, we still move that decimal point. You can see the decimal point in the number this time. We're going to move it to the right this time, until we get it between the 2 and the 3. So our number between 1 and 10 would be 2.367. Our power this time is minus 10, as we move the decimal point 10 spaces to the right. Notice it's also a negative power because the number we're dealing with in this question is very small. But also notice the link between the number of zeros in the question and the number we have as our power. Let's have a look at a couple of questions together on the board. If we want to write 425 million in standard form, remember those examples we just saw where we moved the decimal point. Now the decimal point in this number can't be seen as it's a non-decimal number, but it is there and it's here at the end of our number. Now I want to move it so that I create a number between 1 and 10. And you should see that I therefore want to move it there, between the 4 and the 2. So the number I would get between 1 and 10 would be 4.25. So that's the first part done. I have my number between 1 and 10. I'm going to be multiplying it by 10 to the power of something, because that's what standard form is. And all I need to do now is count how many spaces I moved it. 1, 2, 3, 4, 5, 6, 7, 8. So this number to standard form would be 4.25 times 10 to the power of 8. If we look at a very small number now, such as this one, again we need to think about moving that point, but remember this time our power of 10 is going to be negative because it's a very small number. The more you practice this, the easier it will be to see what that number is that we use between 1 and 10. And in this case, it would be 3.24. Again, we're multiplying it by 10. How many spaces did we move the point? 1, 2, 3, 4, 5, 6. So it would be 10 to the power of minus 6. But notice what was said in the slides that we just saw about how many zeros in forming the number we have as our power for the very small ones. It's always the same as the number of zeros in that number. Another couple of examples, 675.5. Now that isn't a particularly large number, but it can still be written in standard form. So we want to move our point 2 spaces between the 6 and the 7 to give us 6.755 multiplied by 10. We only moved it 2 spaces, remember, so we would multiply it by 10 squared. And the last one, 0.32. People often make a mistake on this one and believe it can't be put into standard form because they forget that the number actually has to be between 1 and 10 and not 0 and 10. So we can move the point in this number one space between the 3 and the 2 to give us 3.2 multiplied by 10. Remember, it's a negative power because it's a number less than 1, minus 1. Now, we've seen how to write very large or small numbers in standard form, but they may well give you in the exam a number in standard form and ask you to write it as an ordinary number. So let's make sure we can do that by looking at a couple of examples together. 5.43 times 10 to the power of 6 first up. Now, the first thing you need to decide in these questions is it a very large number or is it a very small number? And that's always dictated by that power of 10. So this power here is 10 to the power of 6. So we know it's going to be a large number. Now remember, if we were working from the large number into standard form, we'd be counting how many places we'd moved the decimal point in order to work out that power. So essentially we're going to do that but in reverse. Now remember, when we've moved that point, those two moves wouldn't actually give us any extra zeros. So don't make that mistake of saying it's just 543 with 6 zeros on the end, because that's not the case. It moves 2 spaces before those zeros start coming in. So essentially what we have is 543. I've moved it 2 spaces, so my next 4 spaces therefore would be filled with zeros. So my answer would be 5,430,000. And make sure you can see how I came out with that answer. It was the idea of moving the point 6 spaces. Those 2 already had numbers in them, and I filled the rest in with 0. Let's look at one where we have a smaller number. So a standard form number with a negative power of 10 always means it's a small number. And this is where that rule I said about the number of zeros creating that power there comes in useful, because I now automatically know, because my power is minus 3, I start off with 3 zeros, and then all I need to do is to put in the numbers from the question. So it's slightly easier when we're working out our very small numbers, when we're writing them as ordinary numbers, than it is for the larger ones. But practice, as always, makes perfect. 9.054 multiplied by 10 squared. Not going to be a huge number, but we can still rewrite it as an ordinary number. The 2 tells us how many places we need to move the point. 1, 2. So we don't actually need to add any more zeros onto the end of this, as it still stays as a decimal number. And our answer would be 905.4. Final one for a nice small number, 2.113 multiplied by 10 to the power of minus 6. So remember, with these very small numbers, the number of zeros we write is linked in to the power that was already there. So 6 here means I should be writing in 6 zeros in total, and then I can just put in the numbers from the question. 2113.